time to break out the food coloring and these glasses because Chemical Kim is here to show us how to make magical water in some mysterious tablets. Oh, my heavens. And things are starting to explode. When things explode. So are you going to show kids how to do that and scare the pants off their mother?
Well, that actually, you notice how one popped before the other?
Yeah.
Well, in one of the containers, I had hot water, and that one popped quicker.
Oh.
So I'm going to talk about the difference between hot and cold water with chemical reactions.
Okay.
But first, what we're going to do is look at the hot and cold water density.
Okay.
And what you have here, let's feel, is that.
And this is teaching kids what, Kim?
It's teaching them a couple things. It's teaching them about density.
Okay.
It's, of course, teaching about temperature with water. And it's also teaching them about what water does in terms of being lighter, in a sense. Because as it gets warmer, the water molecules kind of spread out.
Okay.
And that gives them less amount of water molecules in a certain amount of space. So that's what makes it lighter, that density.
All right.
Okay, so what you're going to do is add just a couple of drops of red food coloring to these two warm.
Both of them.
Right, and they can do this. You can do this with mason jars at home.
Okay.
This works just fine. And then either an index card, or I found some really rigid, kind of clear cellophane. Okay. And what you're going to do, we're going to switch here. And before I do this, the question to ask is which one is lighter or less dense, the hot water or the cold water?
I would guess the hot, because yeah, I would guess hot.
Right, and if you guess cold, then you do the experiment.
Okay.
Either way to see if you're right.
Okay.
So I'm going to move mine like this, and you then will
Keep
invert
mine
your
like that.
hot onto the cold, and I'm going to do the cold onto the hot. And the technique is to cover this, and it's okay if it spills a little bit, but then you flip it like this, just slide it over, and then of course, like I said, either using an index card. Trust yourself, Lauren, trust yourself.
Okay, I'm doing it right now.
You can do it. You can do it. So just carefully, I'm going to move mine close to yours. Fantastic. Fantastic. Look at that. You trust yourself to let go?
Yeah, I got it.
Got it?
Okay.
Look at that. Isn't that beautiful? See how that hot water...
Oh, it stays right there.
Exactly.
Where that's plunging into that one.
Exactly, because the cold wants to be on the bottom. It has a higher density.
Is this something that, you know, in weather?
Yeah, absolutely.
This is something that can happen in science of weather.
Fantastic. Yeah, where's the weatherman?
I know, he already left for the day. He's had a rough week. We had storms.
Oh,
yeah, I know. But look at it, turned purple.
There's like a little equilibrium's going on there.
Yeah.
Okay, so that is pretty awesome. And maybe if we have a little bit of time at the end, I might have challenged you with doing a couple of Coca-Cola bottles.
How cool is that?
Is that not so awesome? Okay, so talking about the temperature of water and in relationship to a chemical reaction. Okay, again, cold water, hot water. And what we're going to do, before I do this, we're going to do a chemical reaction of using Alka-Seltzer, right? Which
plop, plop, fizz, fizz.
Oh, what a relief it is.
Or scare the snot out of me, is what we did earlier.
Yes. Okay, I'm going to make Alka-Seltzer right in your hand. Okay, so hold out your hand. And the ingredients are... Aspirin.
Okay, seems like that would hurt my belly. Not help my belly.
I know, but these are actually referred to as aspirin tablets, believe it or not.
Okay. Sodium carbonate.
Right, sodium bicarbonate. This is actually baking soda.
Okay.
Believe it or not.
Now that I would get, because it kind of tastes like that when you put it in your mouth when you've had a belly.
Exactly. And then
citric acid.
Right, which is a
I always thought that was just the lime to make it taste better. I did.
Well, the combination...
Okay, so citric acid.
So the combination of the baking soda and the citric acid is what creates the chemical reaction. So when I initiate this with water, what do you notice?
Oh, it's the plop, plop, fizz, fizz right in my hand.
Right there in your hand.
Yeah, it does make your belly feel better.
Exactly.
Because what does it do in your stomach?
Maybe working a little bit, well, the sodium bicarbonate working a little bit with the hydrochloric acid in your stomach.
Okay.
Okay, so maybe there's some chemical behavior there.
Oh,
so I'll let you wipe your hand off.
Okay, good.
I'm going to need your assistance.
I didn't know what you wanted to do. What do I do now? Okay. Okay, good.
Does your hand feel better now?
Yeah, I feel, yes, it's healed.
It
feels good.
It is okay. Good. Okay, so the temperature will affect the chemical reaction. So you're going to take one of these, and I'm going to take this one. We don't necessarily have to do it right at the same time. Okay. But what you want to do is just lift this up, trying not to let it leave the water. And all I did was invert water.
You go first.
Okay. And I'm going to slide the tablet underneath my, there you go, my glass.
Got it.
And you can just use a tall, glass. And what you're observing is cold water reacting the Alka-Seltzer.
Oh, look at it, and that's
Compared
going
to-
away. This is all fantastic.
I know, increase in
You can
chemical
do this
reaction.
at home.
Beautiful.
I love it. And you can find more of Kim's amazing experiments from Chemical Kim on our website at WZZM13.com. Have a great weekend, everybody. We'll see you back here on Monday.